Welcome to Absolute Value Inequalities, hosted by Iridium Tutoring. Absolute value inequalities. Absolute value inequalities are written with an equation surrounded by two vertical lines. The next part of the inequality is the inequality itself. So an absolute value inequality completely put together looks like this. So we have the lines around the equation, and then the inequality, the greater than, less than, greater equal to, or less and equal to. Next, we will talk about solving an absolute value inequality. So we're given an example. The absolute value of x is less than 3. First, we want to find a way to remove the absolute value. Remember that the definition of absolute value is the distance a number is from 0. If x is positive, we can just take off the absolute value symbols to find an inequality, forming this equation. X is less than 3. We just took the vertical lines off. If x is negative, however, we have to do something slightly more complex. This is best explained by directly plugging in a negative number in. Let's use negative 2 as an example. So we have the negative 2 turning into a 2, aka like reversing itself, and it's because negative 2 is 2 away from 0. So that's what this kind of explains, which can be somewhat compared to multiplying by a negative number. So like negative 2 times negative 1 gives you 2. If you wanted to keep the negative 2 in the inequality, you would need to multiply the rest of the inequality aside from negative 2. Remember that inequalities flip when you multiply or divide a negative number. So if we're looking for all negative x, we would have to change the sign. Change the sign from x, absolute value of x is less than, to x is greater than 3. Actually, no. If you were to multiply by a negative number, it would the inequality would be flipped. So another example we have here is the absolute value of x plus 2 is greater than 3, and this can be turned into two separate inequalities. Right here we have basically just the vertical lines taken away, the absolute value taken away, which gives you x is greater than 1. And then for the other inequality, we multiplied 3 by minus 1. But look what we have here. Since we multiplied by minus 1, we flipped the sign over. So what we have here, we flipped over. So this, when we simplify it, it gives us x is less than minus 5. So we have another method. It's called the 4-step boundary algorithm. It sounds complicated, but it's not really that complicated. This is just to prevent extraneous solutions and answers. Extraneous solutions are basically solutions that you manage to solve through algebraic manipulation, but when you plug those numbers back in, they don't satisfy the original inequality. So let's go through this method. So first, we want to solve the absolute value inequality like previously, but replace the inequality with an equal sign. So then this will give us usually give us 2 different x's. And then locate the points on the number line. Test all intervals and points if they satisfy the original inequality. If they do, mark them with a y. for yes. If not, mark them with an N for no. Construct the rays/line segments accordingly. So in this example, we have solved the inequality of the absolute value of 2x minus 5 is less than or equal to 5. So what we did here is we had it, we basically didn't change anything in this equation other than take the absolute value signs off, and then right here we multiply it. Well, we change this 5 to a negative 5. So basically we just multiply this by minus 5, and then this will give us x equals to 5 and x equals to 0, these two x's. But that's not all. Second, we got to locate the points on the number line. So x equals to 5 is here, and x equals to 0 is here. Now we need to test all intervals in points if they satisfy the original inequality. If they do, mark them with a y. If not, mark them with an n. So usually we would want to test, we have the two x's here. We want to test to the left, in between, and also to the right, as well as the points themselves. So x equals to 0 and x equals to 5. So right here, negative 1 is left of 0. So basically we are using one value to test for this entire range. So basically excluding 0 all the way to negative infinity, and that doesn't work for the inequality. What we basically do is we plug this negative 1 in to the original inequality, which doesn't satisfy the original inequality. Now we can do the same thing for the other 4 intervals. So we have 0, the point, and then 2, which represents the range between 0 and 5, and that also works as well. 5, we just plug in 5, that's the point, and that works. And then 6, which represents the right of 5. So this interval, basically from excluding 5 to infinity. So then we can construct the rays/line segments accordingly. So since the interval between 0 and 5 work, as well as 0 and 5 themselves also working for the original inequality, therefore we'll get a line like this, right? We have 0 and 5 both colored in to represent that 0 and 5 themselves work in the solution. Now this can also be represented in brackets 0 and 0, 5 square brackets. This is a solution set notation. And the intervals/numbers that work on the inequality are shaded in the number line. So basically what I just explained here. Okay, this is just another example. We have the absolute value of 2x plus 12 is less than or equal to 4x, and 2x plus 12 is equal to 4x, and 2x plus 12 is equal to minus 4x. So as you can see here, we left this, all we did was just take out the inequality and just put it equal to each other and remove the absolute value. And we did the same thing for the second one, except we also multiplied this 4x right here by a minus 4x, by minus 1. So then solving for x for both of these two equations, we'll get x equals to 6 and minus 2. Now, if we try a number between not including 6 and lower than that, there will not be a solution. So for example, if I choose 0, if I plug x in as 0, or 0 in as x, we'll get 12 is less than or equal to 0, which doesn't work because 12 is obviously greater than 0. So anything to the left of 6 won't work. And you can try it for basically any number to the left of 6 on the number line, and it won't work. But 6 itself does work, and the values after it also works. So the solution set would be square brackets to denote including, right, 6, comma, infinity, which is usually infinity is usually surrounded by a parentheses.